Alright, so our topic of discussion today is going to be Unit 1.9, and this is going to be Part 1. And this is operations with rational expressions. So we are kind of working with rational expressions, looking at how we can simplify them, but we're going to take it one more step, and we're actually going to operate with these things. We're going to start with addition, subtraction, and then move on to multiplication and division. And so our objective for today, for at least this lesson, is to learn the basics of operations with rational expressions in order to apply this to addition and subtraction of rational expressions and continue that on with multiplication and division in later lessons. Alright, so the first thing that we're going to do is we're going to kind of remember how we operate with fractions altogether. So I give you two examples here of two fractions that we're going to add or subtract. And so if we remember kind of what we used to do with fractions before, is that we have to figure out a way to add these. And so the first thing that we need to make sure that we do is that we make sure that we need to have a common denominator. And so the idea here is that we need to make sure that we have a common denominator. So what we're going to do is we're going to look at 5 over 19 and we're going to look at 7 over 38. And again, the only thing that we're interested here is our denominators. We're looking at 19 and 38. And so in order to find common denominators, we find multiples and we can look at factors and everything like that. But the idea is that we might be able to see that 19 is just half of 38. And so in order to do this, we need to do our second step, which is making equivalent fractions. So what this actually is, we have to manipulate our fractions so that we have the same thing. And so we need to multiply the 19 by 2 and we need to multiply the 5 by 2 so that we can get them both to have denominators of 38. So this would then be 10 over 38 plus 7 over 38. And then we can go ahead and then combine. And then what we're going to do is kind of our last step is we're going to simplify. So after we combine, we would simplify if we could. And so what we get here is we get 17 over 38. And 17 is a prime number, so that's where it's going to stop. But the idea is that we have our fraction here, 17 divided by 38. And so the same thing would happen with our next example. We would have to look for our, least common multiple or a common denominator. Now, one way that we can find common denominators that's a little easier than just finding least common multiple is to factor these things. And so when we look at these and we look at the denominators in terms of their factors, this is 3 times 5 and then 3 over 5 times 5. And so what we can kind of do here is we can kind of fill in the missing pieces of these factors so that they all have the same amount. So over here this has 1 3 and 1 5, this has 2 5s. So what I can do here is I can multiply this by 5, and so now both of our denominators have 2 factors of 5. But in order to make this even, to kind of balance the scale here, is that this needs to have a factor of 3 over here. And the second step, which makes us or tells us to make equivalent fractions, what we need to do is kind of remember that phrase, whatever you do to the bottom, you need to do to the top. And so I'm going to multiply this by 5, and I'm going to multiply this by 3. Now, if you look at what I did in the denominator, and that's really where we're looking at most of this, is that if you notice, all 3 of these factors are the same. And so really that's what we're trying to do, is we're going to try to make these factors all be the same, so they're sharing the same factors. And so we have 10 over 75 minus 15 over 75, once I would multiply those back together. And then I could go ahead and I could simplify, which gives me negative 5 over 75. And then now what I can do is I can go ahead and simplify this, and I get negative 1 over 15. And so the idea there is that we're just combining them, and we can look at least common multiple, or what we can do is we can look at them in terms of our factors, and that's what we're going to try to get to with the rest of this lesson. Alright, so how does this work with actual rational expressions, stuff that has variables in them? And so the first thing that we're going to do is we're going to make sure that we have a common denominator. And so when we look at this, do we have a common denominator? And I look at 5y and I look at 5y, so yes, we have a common denominator, and that's the only way that we can combine these. Now the second step says to make equivalent fractions. Well, since we have common denominators, there's nothing that we have to change. There's no factors that we have to add in, nothing else that we have to multiply by, so we can go right on to our next step, which is to combine our fractions, and that means we're going to either add or subtract. Now whenever we add or subtract, we just worry about the numerators, and so we would do this no differently than saying 4x plus 6x, and then we're going to keep our denominator of 5y. And so the idea behind this is whenever we combine fractions, we always keep that common denominator. It doesn't increase, it doesn't decrease, they don't multiply together, they don't add together, it just stays the same. And then if I have like terms, which I do, 4x and 6x are like terms, and so that gives me 10x over 5y. Now, based on what I know about simplifying rational expressions, then I can go ahead and do this. I have 10 times x over 5 times y. 10 and 5 will reduce to 2 and 1, and so that gives me a final simplified fraction of 2x over y. So the idea behind this is that we find our common denominator, make equivalent fractions if we need to, combine our like terms only in the numerator, so if we need to add a note there, so when we look at step 3, this is only in the numerator. We don't touch the denominator stays the same. And then we go ahead and we simplify the way that we know how. So in some cases we might have to factor to simplify, and we can start canceling out factors. But remember, we can only cancel factors, we can't cancel terms. Now that is an example of what we're going to look at here. So when we look at this rational expression, first of all we have to find common denominator if there is one. So if we just investigate our denominators here for just a moment, we're going to look to see what we have there. And so we have this x minus 4 and this x minus 4. And that's what we're going to be looking at. So our denominators are the same, so we can kind of just skip right down to step 3. That tells us that we can combine our fractions. So if we look at what we're doing here, this is simply 4x minus 1 minus, in parentheses, 2x minus 9. Now what we have to make sure that when we're dealing with subtraction, we keep it and we subtract them like they're polynomials. So just like what we did earlier, we have to understand that what we're probably going to end up doing is we're probably going to end up distributing our negative here. So whenever we're working with subtraction, we have to be very careful. And so the way that we can work with this is we can say that this is 4x minus 1 minus 2x plus 9, and then I can go ahead and simplify those by combining my like terms. And then I get 4x minus 2x, which is 2x, and then minus 9, or negative 1 plus 8, which gives me positive 8. And then I have x minus 4 as my denominator. Now notice I kept my denominator the same because I didn't have to worry about it. It's still kind of there. Now what I'm going to do is I'm going to simplify this. Now I'm going to use kind of my ideas of simplification and always kind of look for greatest common factor. So when I look at the numerator, so this is the only stuff that I'm focused on now. So I'm focused on this piece right here now. And so I'm looking for, is the numerator completely factored? Are there any common factors between 2x and 8? And then I look at the denominator. Are there any common factors between x and 4 or negative 4? And so when I look at it, the numerator does have common factors. So 2x and 8 have a common factor of 2. And then I can rewrite that x plus 4. And then I can divide that by x minus 4. Now the idea here is that I want to just make sure that I check to make sure that I don't have anything that may or may not cancel out. Because obviously x plus 4 is not x minus 4. Now if those were both the same, then I could cancel those out and I would just have a fraction left over of 2. But since these have different signs, there's nothing that I can do with that. But I need to make sure that I always completely factor my numerator and my denominator and get rid of any unnecessary fractions or any unnecessary terms. Now here, if we can continue with what we were doing before, there are exclusions that are on this fraction, and that's x cannot equal positive 4. Now if we look at that, we kind of look at and see it from the denominator that we need to make sure that our denominator doesn't equal 0 And as long as x is not equal to positive 4, then we won't have any problems. And so that's just kind of our process with, using these operations with our rational expressions. We're just adding one more piece to it, but we're really kind of working with the same kind of idea with factors and everything like that. Now, what I would like you to do is, if you would like to, I want to see if you can simplify and add these two fractions together, kind of using some of the tools that we had before. So the first thing is, what do you think you could do about making a common denominator? And to give you kind of a hint, these x plus 3 and this x minus 2 are entire quantities. Those are one factor. So think of how you could write things in terms of their factors, what you could create, what you could add. Now this is something that we're going to go over, but I would at least like to give you a challenge if you want to see if you can do anything with this. So see if you could go ahead and add these together. You're probably not going to be able to, but that's okay. I just want to see if you could try it. And then we'll go over this example, the first thing, when we pick up this with part 2.